not flashing. Okay. Okay, let's just see how this goes. Okay, right. I don't normally do politics at all in presentations. Sorry, Jonathan, and sorry to our hosts. But if you are interested or you think it's a really boring subject, the Vice President of Ukraine has 19 channels on Telegram. And if you have the skills and you're not worried about the lawyers and you're not on Rule 4's Wi-Fi network, they will give you lots and lots of hosts to attack. Maybe you're Russian, I don't know, but I wish ports to attack, and they're really looking for intermediate people to play on the red team. It's kind of ironic it's the red team. But anyway, it's actually quite interesting what's going on. So they actually taking down site after site after site, while Anonymous has been taking them off, and of course Evolution belonging to our own NSA. And just the thing, the current rage is TCP middle box reflection DOS attacks. It's the next big thing in network attacks. Anyway, politics are over. This is the Linux Meetup. Who's heard of Dirty Pipe? Okay, good. Well, you haven't heard of Dirty Pipe and you're at a Linux Meetup. You should probably Google it now. It's probably the biggest, it's nothing to do with software supply chain, but it's probably the biggest bug in Linux for a long time. And I will say it's in a lot of the commercially shipping Linuxes. The most recent kernels have a fix. If you don't know what this CVSS3 blah 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 means, hopefully you'll leave the room knowing a little bit more about what that wonderful thing means. Okay, now, because it's a security presentation, and I did use this slide in this room 6 or 7 years ago, no security presentation is complete without one of these, okay? Indeed, and I have to say. So we're going to get the obligatory hacker out of the way. Okay, so I'm going to introduce myself just so you know areas that I understand quite well and areas that I might not understand so well. So I work for Red Hat, I'm a senior principal architect there. I will say it's a great company to work for. They're always hiring, about 20,000 people now. I work in what we call a DevSecOps team. I was hired to teach OpenShift advanced application deployment, but with the coming of COVID and death, I stopped teaching it when it went online. It's quite challenging to teach dev online. So I work mainly with hybrid clouds, particularly AWS, and our own bare metal clouds, and we typically layer OpenStack on top of those. We use Azure a bit. We do have a number of bare metals. Do a ton of Ansible. If you're doing automation, I cannot speak high. Even if I didn't work for Red Hat, I'd use Ansible. It's a great automation platform. And I do quite a bit of OpenShift in Kubernetes. So I started there at Red Hat, and now I'm sort of drifting back into it. Security, as you can see, I have the hoodie. In fact, I have 2 hoodies with me. I used to be a C++ programmer back in the day, so that's always a good foundation. Networking, operating system, C++, I think are fantastic foundations. I think if anyone wants to get into cybersecurity, and it's the mother of all job markets right now, and that's not going to change. I actually think, if you getting that sort of bit of programmer, bit of TCP/IP, bit of networking, bit of operating system, and obviously containers now is a really good foundational background to have. I actually built my first firewalls back in '94, and I was hired by Sun as a security support engineer, and then as a security consultant. I used to do a lot of work with Checkpoint, and it was so much simpler back then. It was all about firewalls, little operating system hardening and firewalls. That's all we talked about. And people used to say, they used to draw their company in a little box and say, we have 2 connections coming in. And so we'll protect those two connections. Sadly, those days are long gone. Okay, so I spoke about these all these years ago. These are not software supply chains, but every once in a while we get one of these branded attacks. You know, these attacks which are so big, they get their own brand, they get their own icons and artwork, and everybody wakes up, not just the security people, IT directors, infrastructure directors, the CIO, I'm not saying the CIO is asleep, VP of development, I'm sorry if any of you are VPs of development, but you know, it raises the awareness, and then everyone, apart from security people, falls back to sleep. Apart from the chief compliance officer as well, who never sleeps. And so these are two of the big ones, but recently we had another. The big attack was this one, Log4j in November 2021. So who heard of Log4j? Okay, right, okay. And this is a software supply chain attack. And one of the fallouts from this is everybody started saying software supply chain, and they started talking to each other about software supply chains, which is not a phrase that I used to use very much. Talk about delivery life cycle, but not so much about the software supply chain. And it got a score of 10, and we're going to examine these scores in a minute. 10 is, well, we'll see where 10 is. Basically, remote attackers, they get to remotely execute code and they get access to your machine. So it doesn't really come much bigger than that. Not only that, 35,000 Java packages in the main Maven repository were found to be impacted by this. So everyone who's downstream of those, building and pulling them into their build systems, even if they're pulling them behind their firewalls and then pulling them into their build systems, they were vulnerable to Log4j with its score of 10. And here we have it even in the land of containers. You know, a score of 10, that's as big as it gets. So maybe this guy shouldn't be quite so happy about scoring. I was going to do Taylor Simpson, but this one just lent itself to. So we'll just have a quick digression. CVEs, CVESSs, and NVDs. So CVEs are common vulnerabilities and exposures. CVSS is the scoring system we use. Great, I should make that a link. There's a great entry in Wikipedia which will break down all those things. We'll have a very quick look at it. You don't have to memorize. I couldn't remember off the top of my head. I can look at one and read it, but I couldn't write it. And then we have the NVD, the National Vulnerability Database. So here it is. The thing on the left, which version? This is the current version. Here's the score, 9.8. That's really bad. That's much worse than Dirty Pipe. The attack vector, AD is the attack vector, so N for network. The complexity, H for hard. Privileges required, none. You don't need to be running as root to be exploited. User interaction. Okay, actually that's incorrect. This is the level, hang on. Right now you don't need local privileges. Scope, this will actually tell you what happens. So unlike a Log4j and some of the other attacks we're going to see, this one, if they exploit you and you're a normal user, they will have your privileges. They won't be escalated. And finally, we have CIA. If people are familiar with the triad CIA, which is basically confidentiality, integrity, and availability. And if you go and get your CISSP, your stuff, and you spend your time hanging out with people who'd say governance all the time, then it's very common language in that world. Okay, so that's what these things mean. It's actually quite useful, you know, because it gives you a way of assessing, and it gives a common language so that people at the network team and the ops team and the DevOps team can all look at it. So we had Log4j, but you know, Log4j wasn't the first big software supply chain. There's been quite a few, and perhaps the first really famous one was Sunburst SolarWinds, where, they're not going to sue me, I feel relatively protected in America, Russia broke in to the software repositories effectively and infected the supply chain of a configuration management platform. 400 at the top of the Fortune 500 were infected. So these people were just pushing it out, and we would all be updating our stuff, and we would be pulling in. So it's a good example of a nation-state attack. In fairness to Russia, I'm going to show you another nation-state attack from the other side. I'm not going to talk you through this diagram, but one thing to understand about this attack, it was phenomenally complex. It was incredibly well thought out. They weren't there to take people's systems down or to do a big denial of service attack. Over many, many months, they were penetrating deep into their targets' networks and just reaping information out and pulling it back in. So some of these attacks are extremely sophisticated, and they're done by professional teams who are basically on salaries. Or I think in the case of a lot of the Russian groups, they do work for the state. Some work for the state. China has groups which work for the state, America has groups which work for the state. But there's also in Russia, you get groups who are tolerated by the state. So they do stuff for the state, and then they go and do some ransomware for themselves. And, the state turns a blind eye to them. But they're not the only bad guys, because Juniper, who knows Juniper? Juniper Networks. So they make firewalls. So what did allegedly the NSA do? They hacked into their source code control system. And they went back in time in their source code control system. They corrupted it and they injected their backdoor into old code. And every time Juniper did a build and shipped a router or shipped new firmware for their firewalls, the backdoor from the NSA was in the firewall. Not surprisingly, their stock price fell 9% when the world realized they were shipping firewalls with backdoors in them. So everyone's doing it. Everyone is doing it. I don't think there's much dispute that it was the NSA. Okay, so let's talk about this stuff. What is this software supply chain? It's basically anything that goes into or impacts your code, okay? So it is a phrase that people are using an awful lot now. They're talking about it a lot more. Last year it was all buffer overflows or whatever. So it's very high on the radar now because the composition of people's code base has changed dramatically with the rise of open source. So virtually everyone is using huge amounts of open source. And we are all pulling it from everywhere. The president has mandated, this only came out, the federal agencies all had to have a strategy. I think this was within 90 days of this coming out. Because within 30 days, to address, amongst other things, software supply chain. This document it's actually quite an interesting document. It's the only federal presidential memorandum I have ever read in my life. It's not something I make a habit of. But it is actually clearly written by professionals. I don't mean professional bureaucrats, I mean professionals. The way they talk about zero trust, the language they use, they're ahead of a lot of people. They're talking about a lot about attribute-based access control instead of role-based access control. It is actually quite an interesting document, but every federal agency is gearing up for this now. 62% of organizations are impacted by it. Anchor software, by the way, and I can use all these. They make all their stuff freely available to use, Anchor software. They just like to be credited with it. Always take vendor stuff with a pinch of salt. Because they're vendors. I'm a vendor. I'm not talking about any red hat technology in this, by the way. But, you know, you always take vendor stuff with a pinch of salt, but I will say, if you download papers from Anchor and Fortinet and SNCC and, you know, Mandiant, I belong to Google, I think. You know, reading the papers, just, you know, as long as you read them objectively, there's a wealth of information there, even if you suddenly find the conclusion means that you should buy Anchor's service. But, you know, there's often, you know, some very, very good data, even if they do ask leading questions. Okay, and as you see, there's Sunburst right at the top. So this was the 2022 survey, so I think it was done in 2021, and remember Log4j was really late in 2021, so I think that's why it's not really appearing there. It'll probably appear in the 2023. They have a 2021 report which you can download as well. I actually downloaded a whole load of this stuff, and I use my Google phone number, so that it gets all the sales reps who call you up afterwards telling you, would you like to buy a firewall? This is the problem. You've seen this one. Okay, this is the problem. You know, your killer application is all pinned up by this tiny little project. And we're going to have a look at someone, because there was one the other day, there was a rare attack about a one-man project. But this is a real problem, I think. If you look at a big application, even a not so big application, there's lots of dependencies. So I was actually working with a team today, literally, and I don't know how many of you are Python programmers, so it was an automation project. We were using Ansible. Ansible's written in Python. And we were configuring Cisco's, Junipers, checkpoints, Aristas, Windows. So we had a very, very small list of dependencies. We needed something called CredSP for Windows. We needed something for this. We needed Ansible. So they gave me something like 8 requirements. When I built the virtual environments for those and did a pip freeze, I had about 40 or 50 packages because they'd all pulled in all their dependencies. And if you showed me that list and asked me to explain to you what each one does, okay, the name, I mean, if it says passlib, I'd say, oh, that's a password library. But, you know, this is what happens. You know, these projects pull in dependency after dependency. They themselves have dependencies. And we're in a world where software supply chains are increasingly intricate, and many developers really don't know what they're running. They're just focusing on what they care about. And if it pulls in PyYAML and PyGinger, things like that makes sense. But there's not a deep understanding very often. And feel free to contradict me. So here's an example. And I took this, by the way, from Sysdig, who actually competes with something that I work with, but it's a really good one. I'll give them credit. So, you know, you think about it. Let's just say you're creating an app. You're going to have your base libraries. You're going to have your own source, third-party packages, maybe some more libraries, and you've got more source code. Then you're going to maybe compile it if it's compiled, etc. You may be utilizing part of the operating system and consuming other servers. So there's a lot of vulnerabilities in that supply chain. And I imagine most of your developers couldn't really tell you, or your VP of development, or your VP of operations, or VP of DevOps really have a good understanding of all the things. Of course, we're now all on containers. That's even better. Even better. We're pulling stuff from repos, from third-party libraries. We've got our own, we've got private repos. We've got our compiler tooling. You know, I mean, imagine, have you ever worked with, who's worked with Maven? I didn't really know that one at all. But it just amazes me, because I used to teach Jenkins pipelines, and they gave me a Java app to use. And I could not believe how much stuff Maven pulls in for what was just a simple teaching application. binary. You've got your binary artifact, you've got your base container image. You might actually have two images. So when we taught people to build on Kubernetes, they were saying, you're compiling, use two images. So you use one, loading the tools, Maven, Java, and all that. Then make a jar file, and then you pull the jar file out and you put it into another image. Or if you're working with C, C++, use GCC or LVM, or Rust. So you have one image which is full of all these tools, and then you build an artifact, and then you pull it out. In fact, we should all be to go, because then you're going to have this nice static binary, and then you don't need any of this stuff. So you probably could have two base container images, effectively. The one which is going to host your runtime, and the one which actually made your runtime. And lots of people use Alpine or SBoMs because it's small. And I bet you, most of you can tell me how you can package management. Maybe you can. You can't see stuff, okay. And then you stick it in your registry. And Natalie just gave me a great. Okay, do you want to share it?
Yeah, sure, I'll share it. So this is in my prior role. We used Nexus. So we had Nexus.top-level domain for our internal use. And the way that Nexus works is it's a proxy. So you can say, I only want to trust these images from Docker Hub. So as this complexity grew and grew, we started adding more than just Docker Hub. We added, GCR for Google. We added Quay. We added GitHub. We added Red Hat. So we had all of these container registries behind one proxy URL. Now, the problem here is that apart from things like Red Hat or Microsoft, the rest are kind of open container registries. There's nothing stopping some random dude from uploading something into Docker Hub. So what I found was a SHA mismatch between a container that I was trying to pull and the container that the canonical pull, the source of truth for that container was on GitHub. And I was like, well, why am I getting this wrong SHA for the same tag? Well, some random dude uploaded a different version of the same tag on Docker Hub. And the way that my software supply chain order of operations resolved pulling this image was to go to Docker Hub first. So I think of it as almost like name squatting.
That's a really good example, and it's not one I'd thought of. I don't do that much. I've done a little bit of work with Nexus, but I've never used it as a proxy. In fact, I always saw that was the killer feature of Artifactory, so I actually learned something there. But we see something actually very, very similar, because we load these things called collections, which are big collections of Python, onto our hosts, and they can live in multiple different places, and then everything that executes can have a different collection path. So we might think we're running off something called Amazon.aws.3.2.2, because that's what we are running off this morning. But it's so easy to make a misconfiguration, and it picks up the one that was sitting somewhere else from 2 years ago, because it's just like a path, your Linux path. If you put your bin or your user local bin, depending where it is, you can pick up the wrong thing. So there's a lot of excitement in the world. There's a lot of room for things to go wrong in the world of software supply chains. So here's just a few attacks. So source code attack. That's where you actually infect the source code itself. So this is the realm, particularly of the nation states, but not exclusively. So NSA, Russian state-sponsored hackers going into other people's repos. But how secure are your repos? And GitHub's actually got more and more secure. So that's what a source code attack would be, and you can imagine if you're a developer, oh yeah, I could see how I could do that. I could just go back, I could check something out, and put it in, and build it in. Download side attack, where you're actually corrupting a site where things are downloaded from. Software developer tool attack, there was a thing called Xcode Ghost, where people thought they were running Apple's Xcode. Typo squatting, jQuery, things like that, where people are creating resources which look like very well. It's particularly in the world of Python. You've got py there, some py. You mentioned parslib earlier, and I think it is called parslib. But if I saw py parslib, I would just say, oh yeah, that was parslib. It wouldn't click with me. Oh, they don't actually have that prefix, because a lot of Python libraries start py, and an awful lot of them don't. It's not py Ansible, it's just Ansible. Patch-side attacks, where you attack the patches, so when the patches are applied, they actually introduce the vulnerability, and insider attacks, where you inject it from the inside. You're actually working with the repo. Particularly, you take some C code. I mean, I'm a core approver on one of our biggest repos, and there's probably 6 of us, but I generally steer clear of Kubernetes related PRs. I did one today because it was a single string, it was a version number. A friend of mine, who's my peer in OpenShift, landed it, and I just happened to spot it. But I generally don't. But I guarantee you, we see sometimes somebody puts in the chat, because you're PR, and they put the URL of the PR, and I go there and I see, there's 8 or 9 commits, 20 files, and I start going through them, and suddenly I see in the chat, approved, so-and-so, who will remain nameless, approved it in a minute. I was like, how on earth did he leave that much code in that many files in a minute? You had to get to the site and go through them all. So, it's quite easy to get things through PRs unless you're very, very rigorous and disciplined. Here's one which came out the other day. Who's heard of Color and Faker? JavaScript libraries. And they're not even that spectacular, but they're massively widely used. And this guy, for years apparently, he's been really annoyed that he makes no money out of this. He's got these 2 projects. So Color does this. If you want to do rainbow text, it actually has a JavaScript function which makes your text rainbow. And apparently, people want to do this stuff, and it was very, very widely used. So people pull it in, some people use CDN, some people use Google, some people reference it directly, and then he got up one morning or whatever, and he introduced code like this into both. So instead of them getting their beautiful rendered text, it started doing everything it did before, but also spitting out loads of garbage. Because he was just a bit sore. And maybe he'd had a bad day or something. And he really is. He's this guy. I don't know if he lives in Nebraska. But it's exactly this. People are building major applications on the back of projects where they really have no idea anything about really where it's coming from, who's making it, what their motivations are. So what can you do? This is actually quite short. This is just meant to give a flavour of, some of the things about software supply chain. There are no silver bullets. It's not going to you can buy a product or put a process in place or hire the right people and it's cured. But you can definitely make it better. And one thing, I've been reading a lot recently, and there's, it sounds a very populist title, Tribe of Hackers. But in Tribe of Hackers, they introduce about 80 or 90, they interview 80 or 90 people across the security industry. Famous people, everyday, operations people, directors, founders, etc. And they ask them questions, and they ask them, what companies can do. And the one thing that over and over and over again, the vast majority of them, is they say it's people. It's really people. Hire good people. And virtually no one, apart from the people who have a product to sell, no one says buy a product. I mean, sure, you might need a product, you might need Fortinet or Checkpoint, but you really need good, trained people more than a tool. Jenkins ain't going to help you unless you really understand what you're going to do with it. So one thing I'd say is provenance. This is really true in the world of containers. So I said I wasn't going to do a plug. I am going to do a plug. So if you want a good Linux container, maybe you want a tiny container, then Red Hat does UBI minimal, Universal Base Image Minimal, and it's one of the biggest, it is the biggest Linux vendor in the business, and it's free. And then they do UBI, which is a bit fatter, and it has, you know, a lot of the basic things. Thank you. And then they do what's called UBI in it. If you need a container which runs system D and in it, and somebody's going to say, why would a container run system D? I use it all the time. I run SSH. I run SSHD in some containers because I use them like VMs. They're just like very, very fast VMs. Beats the pants off Vagrant. But whatever you use, you should really understand it. If you see something on Docker Hub called really fast Mongo, and you say, that sounds good, I like Mongo, you probably want to do some research as to where it came from. And then, do you need Jenkins as a container? You just want to run it on your laptop maybe so that you can do some stuff with Jenkins. Probably go with the official image. There's a number of official images, and Docker and Red Hat with Quay and others will make it very, very clear which those images are. So you want GitLab, use the GitLab image, rather than Freddy's GitLab image, or Freddy's, anyone called Freddy? I didn't hear that. So provenance, that's the first thing. Before you even start doing anything, where do things come from? And so, my boss said to me, why did you install this library? I should hope I should be able to say, why? I'll say, because Sean told me to. Isolate dependencies. Who's heard of 12-factor app? Okay, not everyone. No. Okay, who's heard of Heroku? Okay, so some of you are young. Doesn't mean that people who've heard of Heroku aren't young. So Heroku was probably the first real cool platform as a service. I remember using it. I was amazed because a friend of mine went off to become their chief operating officer when they were really, really little. But they probably didn't need someone with such a fancy title. And I literally, wanted, thought maybe it'd be cool to join this company, and I contacted him, and I actually went onto their site. And I didn't program in Ruby at all. So I just went and looked and found out the hello world in Ruby. This was probably, 2005 or something. And I clicked a button, and it was running. And it was amazing. It was running. It was live on the internet. You just have a file on your laptop. And back then, that was just revolutionary. It was way before Docker. And so they became really, really big, particularly around Ruby, but not just around Ruby. And Ruby was probably bigger then than it is now in terms of mind share, I think. I think Ruby's probably declined a bit. Or Python has certainly exploded. I'm not saying they do the same thing. But anyway, the founders of Heroku, I believe, and maybe some others, went off and wrote 12-factor app. Actually, you know what? This is actually worth a digression. It's a worthy digression. So I used to teach Kubernetes advanced deployment, teaching people how to deploy cloud-native applications. And where's it gone? I thought I had it.
I think you closed it.
I'll get it back.
Command-Shift-T.
Okay, the 12-factor app. And you could argue, the point is not whether your app should have 12 factors. You could say 13, and I've seen people do 13-factor app. In fact, we used to talk about 13-factor and 14. No, but it's just they have these really good principles. And they say you're going to do these sort of things. So this was before cloud native was a thing. Containers hadn't been invented, apart from by some, and BSD units. But they hadn't really been invented in the way we know them today. But they made these rules, and they're still really, really valid today. You know, execute the app is one of the most stateless processes. This was really big with Cloud Foundry. In fact, Cloud Foundry were very, very big onto, and you somebody say, well, yeah, but everybody does that. But these are the people who sort of codified it. You know, we live in this API world, you know, export services via port binding. People say, well, didn't you always do that? Well, no, we didn't really. But their second point was dependencies, okay? Explicitly declare and isolate dependencies. So the first thing you should do is, if you're building these apps, make sure you capture what you're building. And I was talking to a friend of mine, he's a director at a major US financial institution, okay? And we talk, he's an architect, and we talk every month or so, we just chat, and I've got you. So how did you guys deal with Log4j? Because they're huge, and when you're a huge financial institution, you've acquired lots of other financial institutions. So you've acquired their code bases. So you have C and C++ from the 90s, or maybe not just the 90s, you know, big monolithic applications. You have a ton of Java applications. You have a ton of these so-called strangled monoliths, these big monolithic applications, which people have started have started offloading partially onto microservices and Martin Fowler talks about this a lot, and then they've got cloud native services, and then they've got all sorts of stuff. So how did you deal with Log4j? And he really surprised me. He said, oh, well, we told all the developers with outward-facing applications, they had 2 days to patch it, and all the developers who had inward-facing applications, 7 days. But how did you know? He said, you just asked Artifactory. Everything is an Artifactory. And I thought, I've got you. I said, so it's not in GitHub or Git? He said, it's in Git. He said, so you have it in 2 places. That's not very dry. He said, no, Artifactory gets it from Git. So when Log4j broke, they just queried Artifactory, and they had a list of all their applications, and they told all their developers. And they're very much the exception. You know, I was really impressed that they were on the ball, but most people are not on the ball like that. A lot of people don't know the dependencies of a lot of their applications, because so-and-so died and somebody else left and went and took with, you know, what we call tribal knowledge with them. And they can't even recompile it because they don't want it to break. Second thing is, if you like Leon or The Professional in America, you'll remember Gary Oldman, scan everything. Everything. I scanned a repo the other day. It came up with a handful of vulnerabilities. It found the requirements, because I say we do Python well, it found the requirements.txt, and maybe there were 12 explicit dependencies, like, you know, Ansible equals 9.2.27, blah, 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 blah. Scanned that and told us the vulnerabilities. But when you instantiate that as a virtual environment, you're back up to 30 or 40 dependencies. So if you're scanning the wrong thing, you're going to get false negatives. Okay, so scan and use bombs, SBoMs. So lots of scans out there. I can't tell you which are the good ones, okay? I find the company Snick very interesting. I believe that's what you get with the Docker scan, Snick.
They do Docker, Anchor does Docker.
Yeah, so we got Anchor's Sift. We got Sift. So we got Anchor. So Anchor's one who gave those slides. So they are selling something. Their tools are nice. They're free to use. Sift will scan, generate software bill of materials. We'll talk about that very briefly in a minute. Gripe can take those things and turn them into vulnerabilities. So scan. Find a good scanner which works for you, which fits your domain. Do your static code analysis. I haven't got static code analysis on this because it's not. 100% what we're talking about. Though there is the point, you can have something you say in your requirements document sticking with Python, which never gets used. You know, so static code analysis might say, oh yeah, you know that thing with the vulnerability. It never gets called. Or on the other hand, it might see, static code analyzer might say, hey, you realize you call something in the operating system. And that's going to load something which is not in your repo. Because you do a command, or you execute a command with some sort of OS call, and that fires off something. So if you call, say, Ansible and base operating system, you would pick up all its Python dependencies as well along the way, which would be outside of your repo and outside the object you're scanning. So get good at scanning and the scanning tools. Let's just see. Is that at all readable? Can people read that?
Yes.
Okay, let's have a look. I'm going to have to force you to look at my beautiful bin. I am a Visual Studio Code person. No, it's not that beautiful today. Actually, that's a bit unfortunate. Because to make it wide, you can't see it. So homeroom is something, it's a container we use. A lot of my colleagues use it. I hate it. I've never understood why you need to have a 2.8 gigabyte container, which is made up of 30 layers. I think it's called technical debt. Now, so I ran Gripe against it. So Gripe scans for vulnerabilities. Oh, look how big that file is. It's found a lot. Let's have a look.
Is that 69
So you see-
megabytes of text? Did I read that?
So, we start off with a critical. No, you don't want those. And the sad thing about this is actually, it'd be RG critical. How many people use RG? How many people use grep?
I've been meaning to learn RG for a while because I've heard it's
If
easier
you
than
use grep heavily, get RG, rip grep. It's staggeringly fast and it does whatever you want. It does regression, straight out of the box, it does egrep. But anyway, RG, okay, so what have we got? Oh, actually, we've only got 3 criticals. Oh, I think we're going to have to count those. 41 highs. I mean, most people, your policy should not be never put anything in production which has a critical high. You just say to developers, no. 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 And maybe, let's just say, we have something like dirty pipe. And maybe then you have an exception process. But I mean, and this thing actually, we do if we do WC minus L on the actual (583 lines). So there's probably 1 header line, maybe 2. That's a lot of vulnerabilities. So and people put this in production all the time. They love it. It's because it's what they're used to. So there's 2 standards, by the way, for SBoMs. There's Cyclone DX and there's SPDX. They're the 2 big standards. And the anchor papers discuss this in great length. You want to see all their features. But SPDX is one that my company would historically care about. It's all about your licenses. If you want to be GDPR3 compliant or whatever licensing policy, then this will work out all the licenses of all your components, because you know how it's an area I work for Red Hat, I never fully understood. But SPDX, that is what it is optimal for. But Cyclone DX is optimal for vulnerabilities. Now remember, if you do a build or a PR, merge to main, you can generate your SBOM then. Because it's fixed. And you don't do anything to that code base for 3 months. That's fine. But you want to be running tools like scanners daily. Because vulnerabilities change. So your libraries might not change, but vulnerabilities in those libraries may be discovered tomorrow. I mean, once upon a time, nobody knew about Log4j, but it was out there. And then the next day they did. So be aware of that. So you should generate SBoMs. Whenever, so I was just arguing with these guys today. I said, what version? They said, just run latest. And I said, latest? And what do I tell ops? That they're going to run latest. And what happens if they do it tomorrow? So if I run latest on there, then ops run latest on, is it going to be the same latest? So, so that's why that dependency rule is so well. But with the SBOM, generate your SBoMs, put them in pipelines. Natalie, you can teach everybody how to do GitHub Actions.
I use Gripe and Sift on all my computers.
Or Jenkins. If you're a cool kid, learn Tecton, the Kubernetes OpenShift pipeline, where every stage in the pipeline is a container. And they can pass data between each other. So if you think of a Jenkins pipeline where you've got 5 phases, a Tecton pipeline is 5 containers. To do the equivalent. I mean, often they're going to be a lot bigger. That's really, really cool, actually. Because if you think about it, does anyone like writing Jenkins pipelines?
If I never touch Jenkins in my life again, it will be.
I think that's the future. Some of my friends tell me this, and I don't know Tecton particularly well.
That sounds really cool, though.
Now, there's lots of other things you can do. So, the very fact that Natalie was talking about Nexus, bring everything behind the firewall. If you know that you've got jQuery, you know it is the real jQuery that you love, and you're still using jQuery, bring it behind the firewall. And then when you build, it's your copy, your golden copy, as opposed to some random copy of the internet. But the more stuff you bring. I mean, if you look at the big compliant organisations, PCI compliant, HIPAA compliant, big financial institutions, they don't let people go Docker pull. They just don't actually Docker pull HTTPD. Or there's a good typo actually. You could put an extra T. You could actually publish an image called HTTP PD. And that image must be so popular, that Apache image. Sooner or later, somebody's going to pull in that extra image, which would be your special version of Apache. So I think that's a good topic. Bring it in behind the firewall, lock it down. But at the NSA are on their way. You'll be using Juniper firewalls, so they'll pass straight through those, and then they'll go to your code base. Shift left. This is kind of another. I don't know how long have people been saying shift left. Do people say shift left?
I have a slide somewhere from 2005 from IBM, I think it was, talking about the cost of bugs in production, and then the cost of finding it at QA, and then the cost of finding it in development, and it's kind of like this nice exponential curve. So we've been talking about shift left for quality for at least 15 years.
Right, so I mean, the three of us and some of you were in this room a few weeks ago when Trent was doing that, the DevOps culture chat. And I thought that was good. I really enjoyed it. I thought I didn't want the DevOps culture. I thought it was really good. But if you think about it, everything's moving to the right. Your small pieces of work are moving to the right. And if you read DevOps Handbook and everything by Gene Kim and everyone, well, that's a feat in itself, actually. I'll take my hat off because it's heavy going. But obviously, if the bug is caught at the end, it's a huge amount of rework. It's gone from the developers, it's gone through QA and through testing, etc. Other things have been brought together. Maybe it's part of a much larger application, and then there's a bug or a security vulnerability, and you push it back to the developer who's completely forgotten quite why he wrote the loop in that particular way. It seemed very cool at the time. but he's forgotten quite what it does or how. And that's expensive. But if you push this code in, and it comes straight back, or maybe it comes back in 20 minutes, he still has context, it hasn't gone downstream, nobody else has wasted any time. So shift left is definitely a lot of people are talking about it again at the moment. Shift left, push it back on your developers. Don't let it move to the right. Don't let it move. Catch it before it gets any closer to production, because it's so much cheaper to catch if it's the developer who did it or whatever, or if it's just 2 steps beyond the person who originally introduced it, which might have been me. I said, I'll make you a virtual environment. And they say, hey, that virtual environment you made, it really sucked. Or that container image. Because you can have teams who make container images, like we'll make you a golden Python. All Morgan Stanley Python applications have to be on the Morgan Stanley golden Python master, for example. And then they just say, from Morgan Stanley golden Python master, whatever they want to call it. So I definitely think that's the topic. Build it into your CI/CD. Yeah, really do. And just be aware, people need to be educated, because I think when Docker came out, I was just putting things left, right, and center. I said, oh, this is great. Whoa, I'm running Jenkins, I'm running GitLab. I couldn't believe how easy it was to run stuff. And I think a lot of people like that. And the same with pip. We're pipping stuff all day long. And I'm going to let you go, but I'm just going to actually do this. I'm just going to do rg pip tilde dot. I haven't practiced this. This is just out of my CSH history. Oh, let's have a look. Let's have a look. So I had 214 calls to pip. And then, of course, a lot of them actually install many, many things. A lot of them consume requirements files. So, parse.it doesn't have a PY. Okay, questions, experiences to share, war stories? Thank you. And thank you for sharing that next as well. I'm going to use that story.